The solution of this function, when we graph it, it looks like it's going to intersect about that point there. And we can find that on a graphing tool. We can just touch that point and find that solution. So I've graphed here the left-hand side in y1, and I've graphed the right-hand side in y2. Okay, and the solution is going to be there. And we know that the way the quadratic's going to work, eventually there should be some solution up there as well. So let's look at this algebraically. So we can just find the solutions. We can sketch our graph and we can find the intersection of this point. And because the quadratic is going to get steeper and steeper, eventually this line has to cross. So let's look at this solution algebraically. Okay, so when we solve these algebraically, we have to consider two possibilities: when the inside is positive and when the inside is negative. So there's a few ways we can do this. I'm going to set it up this way. So solving this algebraically, I'm going to have x squared plus 2 absolute value equals, this is going to be 8x minus 5. So at this point, I'm going to set up my positive and negative possibilities. So x squared plus 2 could equal 8x minus 5. Okay, so that's my positive possibility. And my other situation is going to be the opposite. So negative 8x plus 5. And solving these two equations, I'm going to end up with x squared minus 8x plus 7 equals 0. Solving this, I'm going to factor x minus 7. X minus 1 is equal to 0. So I get a solution of x equals 7 and x equals 1. So there's my algebraic solution for that portion. That's the positive version. And then I'm going to go ahead and solve for the negative version here. X squared plus 8x minus 3. Okay, so there's my negative version. I'm going to solve this, and that's equal to 0. Solve this. It doesn't look like it factors, so I'm going to solve this using the quadratic formula. So x is equal to negative 8 plus minus square root of 64 minus 4 times a times c. And that's all over 2a. Solving this, negative 8 plus minus, this is going to be 64 plus 12, or 76, over 2. And simplifying this, I get negative 4 plus minus. I can factor the 4 out. I'm left with 19. So I'm left with square root 19. Okay, so those are my solutions. When I plug these back in, I can check. Okay, so when I check these, so this would be my check. So x equals 7, and I can see that x equals 1 and x equals 7 is probably going to be my solution. And when I take a look at 4 minus root 19, it looks like that's going to be a negative number, and we don't have any negative solution. So when we check it, we're going to see that we end up with 49 plus 2 absolute value is equal to 56 minus 5. Yeah, that's correct. We plug 1 in there, we get 1 plus 2 absolute value, and I end up with 8 minus 5, which is 3. So those both check out. So this is x minus 7 and x equals 1. I end up with 1 plus 2, and that's going to be 8 minus 5. Okay, so those are both perfectly good solutions. And I see those ones are the ones that are going to show up on my graph here. So there's x at 1, and then when we extend this graph like that, there should be a solution at 7. Now when I check these other solutions, what's going to happen is they do not fit my outside restriction. Okay, so when I plug this in, I'm just going to I'm going to check these solutions here. And I'm not going to actually calculate the values. I just know that this value here is approximately negative 8 point something, dot, 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 and negative, so if I add square root 19, oops, that's going to be about approximately positive 0.9 or something like that. Okay. Actually, we should work that out a little bit more. Square root of 19 is going to be about 4 point something, right? 4.3 or something like that. So we end up with approximately 0.3. Okay? So when we plug those numbers in to our test, so I check. I'm going to check x equals negative 4 minus root 19. When I check this, notice what happens. I'm going to end up with some positive in here, okay, some number on the left hand side, and I'm going to end up with a negative number since x is going to be a fairly large negative number. If I plug it in here, I get about negative 6470 minus, this is a negative. So I end up with a positive equals a negative. That can't happen. We know that this must be extraneous. And when I check x equals negative 4 plus root 19, well, that's not going to be a very big number. So when I plug that in, on the left hand side I have absolute value, so that's going to be positive. And when I plug in into my x, 8 times 0.3, it's going to be about 2.4 minus 5, it's going to be negative on this side. And again, that can't happen. Okay, so this is also extraneous. So these two solutions do not work when I actually sub it in. Now, if you were observant, you may have recognized that when I have x squared plus 2, this can only be positive. And so we only really needed to work out this side of the equation, because this side, based on a restriction that this inside is always positive, we didn't actually need to consider this solution here in red. So whether we do it graphically doesn't lie, the actual solutions show up, so these two solutions show up. Whether we do analysis and we eliminate the negative version because of this fact that this is always positive, that's perfectly fine. Our last resort, but it is the most reliable, but it is the most work, is to check our solutions, right? To test every solution, to solve for everything and test every solution. That's very reliable, but can be time consuming. So if we can avoid that by seeing some arguments here that x squared plus 2 is always positive, we actually do not need to consider this whole red solution here. When we are solving for these absolute value equations, it is good to know how many solutions might we be looking for. So when we look at this problem here, the absolute value of a quadratic plus 7 equals 25. Well, I can simplify this to my quadratic absolute value is equal to 18. Okay, so subtract 7 from both sides. And I should really consider 4 solutions. Now why? Why do I need to consider 4 solutions here? Well, this could possibly, the shape of this graph, the absolute value part of the graph, could look like this. Okay, it's this W shape. And if it's going to equal some number, we know that y is a horizontal line, and there could possibly be 4 solutions. Now, given this shape, it could possibly be only 2 solutions. That's possible. It could be 3 solutions just touching there. We could have no solutions. We can have 2 just touching on those parts. There are lots of possibilities, but we need to consider that there could be up to 4 solutions, and when we solve this algebraically, we need to make sure that that has been accounted for.